Hello. So you're looking to do secondary port calculations for the Yachtmaster exam, and you are looking for a way to understand the process of calculating adjustments for secondary port heights and to calculate heights of tide in a secondary port. So just a short explainer as to what the underlying theory is, the underlying idea of secondary ports is, and these are the smaller ports. We've already looked at the standard ports. So I've got an example there of Plymouth there with the standard port curve there, and the major ports. The major ports have published tidal information for them, but they wouldn't have tidal information for the smaller ports nearby. For example, in that neck of the woods there, we've got lots of other little ports nearby. We've got Torquay further around the corner, Tidal, the River Exe there. So these are all secondary ports, and if we included the full tidal information for every small port, the Almanac, which as you can see is pretty big, would be so big that it'd sink the boat. So we assume that the water's going to move in and out of the smaller ports near the standard ports in pretty much the same way as it does in the standard port. So we use the standard port's tidal curve there, and we can think about it logically when we look at the flood tide here, that the high water, if it reaches the standard port, it would reach the secondary ports upstream a bit later, and it would arrive at the secondary ports downstream a little bit earlier. So there'll be an adjustment for the time of high water. It might be before or afterwards. So that's what the secondary port calculation tables are for, is to tell us how much before or after the time of high water in the standard port that it is. So another thing that can happen is the topography of the area could mean that there'll be a difference in the height of high water and the difference in the height of low water. Now, how much this difference is going to be given to us from the corrections tables that are in the Almanac. So the corrections tables give us the times of high water in the standard port and the differences that we would find in the secondary ports. This is an example from the Yachtmaster syllabus, and the imaginary port of Rosal Cove is further south than the standard port of Port Fraser, and the tide is sort of assumed to be coming in from the south if we looked at the tidal flow. So it gets to Rosal Cove earlier, and if it came in at midnight or midday, it would be 30 minutes earlier. That is to say that it would be 11:22, or it would be 11:22 at night, 11:22 in the morning or 11:22 at night, 38 minutes earlier. And if it was 6 o'clock in the morning or 6 o'clock in the evening, then it would be 5:42 in the morning or 5:52 in the evening in the secondary port. So the complexity arises when the time of high water in the standard port is not exactly on one of these times. Why are they different? Well, that's to do with tidal theory and spring and neap tides there. The way the water moves on a spring tide is going to be at a different rate to how it moves on the neap tides, and that's going to affect how quickly it arrives at the secondary port after it's been at the standard port, or how much before it gets to the standard port. So you can think of it as due to springs and neaps, but really all we need to do is compare the time of our high water in the standard port to the time of high water in the table and make an adjustment based on that. So I would use an example of if we had a high water in Port Fraser of 3 o'clock, that would be halfway between these two, and we'd interpolate between these two numbers. Note that if we had high water of 7:30, 07:30 in Port Fraser, we found that in the Almanac, it's 07:30, that would be between the 6 o'clock and the 12 o'clock. So we would interpolate between the -18 and the -38. So you're sort of going diagonally there. So you look at the times on either side of the time that you found for high water in your standard port. And a similar thing will happen with our high water heights, which are these two, and our low water heights, which are these two. We'll find out the height of high water in the Almanac for the standard port, compare it to these two numbers and interpolate between these two numbers if necessary. And the same for low water. And we put all of that information into the tidal curve for our standard port.